Now, series A, series B, series C is there. Okay. So we're looking there. So you can see for all the three different series, you are having the same mean value. That means you are having same average value. Okay. Here also your average value is 200. Here you are having average or mean value is 200. Here also you are having average or mean value is 200. So from here, can you say that all these three data, they are exactly same?
No, sir.
So what difference you are seeing?
The distribution of values.
Distribution value is okay, but can you elaborate? You can see the first series, all the data are exactly to 200. The series A, all the values are exactly 200. They are not debating. They are exactly same value 200. Second one, they are debating little bit, but values are close to 200. So when you are saying that class average, for example, in your class some exam is there, students are having many different values, okay? When you are saying that class average is let out of 50, your class average is 32. So what does it mean? It means that almost all values are close to 32. That is what it means, na? When we are saying, for example, in your class maths or this course, okay, this tax course, out of 50, your class average is 32. So class average is 32 means what? If you are saying someone that, okay, here we are having B1 slot, class average is 32. And let's another B2 slot, class average is let 35. So what does it mean? It means that almost all values are close to 32. Getting or not? But thing is that 32, someone's value may be 31.5, someone's value may be 33, someone's value may be 50 out of 50, someone may got 0 out of 50. Getting or not? So the deviation is also happening. So that how we'll measure. That is the thing. So you can see the series one, all the value, all class average is 200 and everyone's value is same 200. So no one is deviating. There is no deviation. All values are exactly same 200. Second one, there is little bit deviation, but values are close to 200. Values are close to 200. Here, so this is close to 200, almost equal to 200. But here, series C, can you say all the values are close to 200? Although you are having same average value, but can you say values are close to 200? No, not a single value is close to 200. Whether 1 is close to 200, whether 989 is close to 200, whether 2, 3, 5 are close to 200. No, not a single value is close to 200. Correct or not? Although your class average is same 200. So there is so much error is there. Here so much error is there or not? When you are saying section C, series C means section C, okay? Section C, the class average is 200 when the teacher is saying. So what other people will think? Other people say, okay, marks are close to 200, it should be close to. But whether single value is close to 200, no. How much deviation is there from 1 to 200, 989 to 200? Getting enough. So by saying only the class average, it will not represent the data perfectly. Getting enough. So you need to find the deviations also, how much it is close. By only saying the mean, it will not represent the data perfectly. Getting or not? So we need to find the deviations. Deviations from where? Deviation from mean. We can calculate from median also. So these are all central tendencies, okay? Center values. Getting or not? So we need to represent the data with respect to the deviations also. How much they are deviating. Although you are saying the class average is 200, but that does not mean the data will represent or data will be close to 200. So you need to represent the deviations, correct or not? I think you know these things. So there are different ways are there how we'll calculate the measure of dispersion means the deviation, okay? How much it is deviating or how much it is dispersed, how much it is distributed. So the measure of variation, it is also called as the degree to which the numerical data tend to spread about an average value is called the variation or the dispersion from of the data. How much it is dispersed, how much it is variation it is having. So you are having so many different ways that you can find the range, you can find the quartile deviation, you can find the mean deviation, you can use the standard deviation. So whenever we are talking about the measure of dispersion, the most popular method is the standard deviation. Okay, when someone is talking about the measure of dispersion, primarily we used to use standard deviation or variance. Okay, but you are having other measures also like range, you are having quartile deviation, those are also important. In our day-to-day life, we used to use standard deviation and variance. So we'll see one by one. So here's the range. So one is the absolute value and another relative value. Okay, relative with respect to someone. We'll see. So range. So what is the range? So you know the range is nothing but the difference between the upper limit and the lower limit. Okay. So here when your data, the discrete data are there, so you find the largest value, you find the smallest value, and the difference between the largest value, smallest value is nothing but the range. Okay. This is the smallest value, this is the largest value, this difference is nothing but the range. And so this is the absolute value, and the relative measure is nothing but the coefficient of range. So here this is nothing but the largest value minus smallest value divided by largest values plus smallest value. Okay, this is the with respect to, so you are calculating. So this is coefficient of range. And so you can have one example here. So range is having very minimal use, but still it is there. So you go through it. So here you are having the data. So what is the largest value here? So you can see the largest value is 250. Okay. What is the smallest value here? Smallest value is 160. So the difference, the range is nothing but 250 minus 160, 90. And coefficient of range also similarly you can find it. Okay. And there is another example here for the continuous case. So continuous case, what is the largest value here? So the largest value here is the 70. Okay, the upper limit. Here the largest value. What is the smallest value? Smallest value is 10. Okay, so here the range is going up to 70. So 60 to 70 means it can be 60, 60.5 or 66, 67, 70. Okay, at last it will reach maximum value will be 70. Lowest value it is starting from 10 to 20. It can be 10, 10.5, 10.2. So the lowest value is 10. The range is nothing but 70 minus 10, and you can find the coefficient of range also. Okay. So we'll discuss the quartile division. So you know what is the Q1, what is Q3, what is Q1, what is quartile? Quartile is dividing the whole data into
4 parts.
4 equal parts. Okay. Q1 is nothing but the 1/4 of that. Q3 is nothing but the 3/4 of that. Okay. So the quartile deviation is nothing but the difference between the average distance, the difference between the Q3 and Q1. Average. So divide by 2 is nothing but you are taking the average. So average. So average amount by which two quartiles differ from the median. Okay. So here you can see. So here you will have, what is that? Here you are having. So this is your Q1. This is your Q2. This is your Q1, this is your Q3. Okay, So Q3 minus Q1 will be some value, and so Q3 is nothing but this position, what is the value, and Q1. And if you are taking the difference, then if you are taking the average, that is going to be your quartile deviation. Okay. And from the median, if you are adding that quartile deviation, so this is nothing but the 50% of the observations. Okay. This is nothing but so this distance, this Q1, Q3 difference divided by 2. So if you are taking that median plus minus quartile deviation, median plus minus quartile deviation, then you are going to have 50% of the observation. So it is going to cover 50%. So when the quartile deviation is very small, it describes high uniformity or small variation of the central 50% items, and a high quartile division means that variation among the central item is very large. Okay, that is obvious. Here we are going to have this is called the absolute, what is that, absolute measure, and the relative measure is that coefficient of the quartile deviation. Okay, so the same way, like if to find the coefficient, what is that, first initial we calculated the relative measure for the, what we calculated, the relative measure for the range. Okay, the same way, exactly same way, we need to find the relative measure with respect to the quartile deviation. So that is called coefficient of quartile deviation. Many people, they used to ask this one during the lab class also. Will ask you how to find the coefficient of quartile deviation. Okay, and even in your lab fat viva also they used to ask the coefficient of quartile deviation. Even in that I mentioned in last class na, your cat 1 exam or fat exam, one question will be definitely will be there to find mean, median, mode. There they will ask you what is the coefficient of quartile deviation. Okay, so this is very much important. So coefficient of quartile deviation is nothing but Q3 minus Q1 divided by Q3 plus Q1. It can be used to compare the degree of variation in different distributions. So coefficient, so here we are having one example. So the data are given like that. So you need to find what is Q. So first you need to sort the data, then only you can find the Q1 and Q3. Na? So you sort the data in increasing order, the lowest value is 12, then you are having 15, then you are having 20, then you are 28, 30, 40, 50. So how many there? 1, 2, 3, 4, 5, 6, 7. So total you are having n is 7. This is discrete data. So now tell me what is going to be the Q1 value? Q1 value will be 1/4 of n. So this is discrete data. You have to take n plus 1 divided by 4. This is the position. This is not the value. This is the position. Okay. So value, what is there at this position? So n plus 1. So that means, what is that? 7 plus 1 divided by 4. So this is nothing but the second item, second position. Okay. So what is the second position? Second position is 15. So your Q1 is going to be 15. Similarly, what is Q3? Q3 is nothing but 3n by 4 or 3n plus 1 by 4. So what is gap? That is going to be sixth position. What is that? That is going to be sixth position. So sixth position is here you are having. So six, this is your Q1, this is your Q3, and the quartile deviation. What is that? Quartile division is Q3 minus Q1 divided by 2. So Q3 your value is 40. Many students they used to write Q3 equal to 6, Q1 equal to 2. That is wrong. Not 2. This is second position. What is that? Second position. Many students they used to write Q3 equal to 6. No. 6 is not. This is the sixth position. What is the value at there in the sixth position? Getting so quartile division is nothing but Q3 minus Q1 divided by 2. So what is Q3? Q3 value is 40. Q1 value is, what is that? 15 divided by 2. And coefficient of quartile division similarly Q3 minus Q1 divided by Q3 plus Q1. You will get the coefficient of quartile division. So compute the value of quartile deviation and coefficient of quartile deviation from the following data. So this is given, the discrete data is there. So you need to find the quartile deviation. So first you sort the data in increasing order. So here, okay, so they have here, they have here. Okay, sir, here you are having the frequencies there. Eh? So frequency is there means, so the problem will happen here, because here there the only discrete data only single time was there. Okay, yeah, so this is only the rule number and there is no frequency. Here you are having the frequencies there. So frequency, why you have to treat it differently? So you can see, for example, the quartile, the Q1 position is, let your position is 13th position. So 13th position, where it will lie? It will lie here or it will lie here. Where it will lie? That you have to decide. So how will you decide that? The 30th position is where? So you have to count the cumulative frequency. Then only you can find the position. Otherwise, you have to just do it manually. Okay. You can add here 4 plus 7. So what is that? It is going to be 11. Then 11 means 13 will be in next series. Here it will be in the 13th data will be here. So that thing you need to check it, but manually. Otherwise, better if you are doing like that, how the teacher will know that how you have done. Okay, so better you explain it elaborately. Now how to do that? You have to use the cumulative frequency. So here we are making another column, cumulative frequency. So the first is only 4, then 4 plus 7 is 11, 11 plus 15 is 26, 26 plus 8 is 34. Means up to here you are having 34 data, up to here 26 data. If your position is 28, where it will lie? It will lie here only, because this one is containing from 27th position up to 34th position. Getting or not? And here it is starting from, what is that, 35th position up to 41st position, and this one is starting from 42 position up to 43 position. Okay, now, so total how many data you are having? Total you are having 43 data you are having. Okay, this is the discrete data. You have to use n plus 1. So what is the Q1? Q1 is nothing but 1/4 of n by n plus 1, 1/4 of 43 plus 1. So this is nothing but 44 divided by 4, and this is nothing but 11th position. So 11th position, you can see 11th position directly lying here. Where? Here you are having the 11th position. So the 11th position item, what is that? Item is 20. 11 is not Q1, 11th position. Getting or not? Q1 not 11, 11th position. I am repeating again and again. Many students used to do the same mistake in exam, in CAT 1 and FAT. So Q1 is nothing but the 11th position, but what is the data? Data is 20. So Q1 is 20. Similarly, you need to find the Q3. So Q3 is nothing but 3/4 of n plus 1. So 3/4 of n plus 1 means it is 43 plus 1, 44. So this is nothing but, what is that? 33. Q3 is not 33. It is 33th position. Getting or not? So 33 position, where it will lie? It will lie here only in this group, because this is containing up to 34 items. Okay, so that means your 34th position, so 33 position, what is that? 33 position is, the data is 40. So this is going to be your Q3. Getting or not? Then you find the quartile deviation. Why everyone is silent? No one is responding. Are you getting or not? Hello.
Yes, sir.
I can understand the morning class. Okay, so quartile deviation is nothing but, what is that? Q3 minus Q1 divided by 2. So Q3 value is 40, Q1 value is 20, and you just take the average of that difference, and that is nothing but 10 units. Okay, So quartile deviation is this one, and the relative measure is nothing but coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q2. We are going to get 0.3. Similarly, you are having now the continuous data, the class data you are having. So how to deal with this? How to deal with this? Hello? How to deal with this? Hello?
Yes, sir.
Tell me how to deal with this. How to find Q1, how to find Q3. How to find Q1? This is very simple problem, na?
Yes, sir.
So what to do?
Cumulative frequency.
Exactly. So we have to first go for the cumulative frequency, because when frequency is there, you can do it manual, but it will be very confusing. Okay, better you find the cumulative frequency. So 10 to 20, 20 to 30, 30 to 40, then 40 to 50, then 50 to 60, then 60 to 70, 70 to 80 is there. Okay, and here the frequency also given. The F frequency is given 12, and here you are given 19, and here it is giving 5, then it is given 10, then it is given 9, then 6, then 6. So better to go for the cumulative frequency. So it is 12, then 12 plus 19, what is that? 12 plus 19,
Even
next, sorry, correct,
36.
yes, next 36, next
46.
36, next
55.
next
61.
67. So your total n is 67. Okay. So if your n is 67, so what is going to be the Q1? Q1, what is the Q1 is going to be? What is the Q1 position? What position is going to be the Q1 position?
N by
N
4.
by 4.
N by 4, because it is continuous, so you have to go for n by 4. So this is nothing but 67 by 4. So what you are going to get? 67 by 4. Use the calculator, na?
16 points.
What you are going to get?
16.7.
16.7. So 16.7 will lie in which class?
31.
In this class, this is going to be the Q1 class. This is going to be the Q1 class, because you can see the first one is containing only 12 data. So 16th position will lie in this class. You can do it, you can check it manually, but if it is 31, then you can do it that way also. Okay, better you find the cumulative frequency. You will not get confused, you will not do any mistake. Okay, so 16.7, this position is lying in this. So this is your Q1 class. This is your Q1 class. Okay, so in Q1 class, so what is the formula to find Q1 for the continuous? What is that? Exactly similar to the median. Exactly similar to the median. Same to same formula, nothing different. Q2 is same as your median. Q1 also. So in median formula you are using n by 2. In Q1 formula you will use n by 4. And Q3 formula you have to use 3n by 4. Otherwise formula is exactly same to same. What is the formula? Formula is, tell me, L plus
H by F.
H by F, then
N by 4 minus CF.
so here, or you can write L1 H1, F1. Okay, so to differentiate between Q1 and Q3, I'm writing here L1 because they are also for Q1, Q3. You also will use another L also, na? So that is why I'm using. Okay, one I'm using for Q3. I'll use 2. You will get confused. So here, what is the L1 value? Which one is the L1? L1 value is. What is
20.
L1 value? L1 value is 20 here. And what is the H value here? Or H1 value is?
10.
H1 value is 10 because the class width is 10 units. The difference 20 minus 30 is 10. Then what is F1? F1 is nothing but
19.
19. The frequency of the Q1 class, and n by 4 you know n is 67, no need to worry. And CF1, what is that? Cumulative frequency of the
Preceding class.
preceding class, what is that?
12.
CF1, 12. Okay, you just replace everything. So you are going to have, so L1 value is 20 plus 10 divided by 19, n by 4 is 67 by 4 minus CF1 is 12. Okay, you calculate and find Q1. Similarly, what is going to be the Q3 value? So how to find the Q3 class? So Q3 class is how to
3n
do
by
3n by 4. So 3n by 4, what is that? What value you are going to get? Same 67 by 4, you got 16.7. You just multiply with 3. So what we are going to get?
Sir, it's 16.75.
16.75.
75. It's not 16.7.
Okay, 16.75. So what you are going to get?
50.25, sir.
50.2.
50.25. Okay. So 50.25 will lie where? Which class will belong for Q3?
50 to 60.
This is the class for Q3. This is the Q3 class. Okay. So here, what is the L2? So what is the Q3 formula? Q3 formula will be. What is Q3 formula will be? Same to same. L2 plus H2 divided by F2 into
3n by 4 minus CF.
3n by 4 minus CF2. Okay. So what is your L2? So here L2 value is 50. And what is H2? H2 value is 10. What is F2? F2 value is 9. What is CF2? CF2 value is, what is
40.
CF2? 46. Okay. So you replace everything. So this is going to be 50 plus 10 divided by F2 9 into 3n by 4, 3 times of n by 4 is 60. So 3n by 4 already we calculated na 50.25. So this is 50.25 minus CF2 is 56. Let us see we are getting the same answer or not. Yes, so this is same 20 plus 10 by 19 into 67 by 4 minus 12. Yeah, same. So you are going to get Q1 value as 22.5. And Q3 value is Q3 here they have calculated. So 50 plus 50 plus 10 by 9 into 50.25 minus 46. into 50.5. So you're going to get 54.72. Correct or not? So we calculated the Q1 and Q3. After calculating, then you just find the quartile deviation. What is quartile deviation? Q3 minus Q1 divided by 2. So your Q3 value is 50.4.72 and Q1 value is 22.5 and divided by 2. So 16.11 is quartile division. Coefficient of quartile division is Q3 minus Q1 divided by Q3 plus Q1. You will get 0.4172. Got it or not? Is it okay to everyone? Hello.
Yes.
Yes, sir.
So similarly, you are having mean deviation. Mean deviation means deviations from the mean. Okay. So, and you need you need to find the average mean deviation. The deviations you can calculate from the mean or median also. So the mean deviation is the average of the difference from the between the observation in the distribution and the median or mean. Okay. So in general, the mean deviation they used to take from the median. You can go for the mean also. So you have to find the deviation from the median position and you have to average it. Okay. You have to take the average of that. So you just take the all the, or means you have to take the difference irrespective of sign. So that is how you can manage by taking the mod. If you're taking the mod, then sign will be ignored. Why so? Why mod is so important? See, sometimes the deviation will be minus. For example, your data, if your the median value is, for example, 2, okay, and the data is 1, like 1 2 3 4 5. So here, so 1 minus 2, the what is the deviation? Deviation is here -1, getting another. Next deviation is 0, then 3 2. So that deviation -1, and when the deviation is next you are having plus some, then at that time the deviation, the difference will be get cancelled and it will show that there is no deviation 0. Getting another. So to check this one, we need to take the mod. If mod means the deviation, we have to ignore the signs. Okay. If -1 also, we will consider this as a +1. -2 is there also, so we will consider as the +2. Then we will take the average of that and we will get the mean deviation. Getting or not? Why we are taking the mod? Mod is very much important for this. Understanding or not? Why we are taking the mod? Sometimes it will be negative, sometimes it will be positive. It will get cancelled, na? Not only 0, it can be any value, okay. But thing is that the deviations, it will not represent perfectly because the signs will be adjusted among themselves. So to take care of that one, we need to ignore the signs. Only we'll see that how much it is deviating from that position, irrespective of the sign. It may be less than, it may be greater than, whatever may be, but we have to just check the difference. Okay. So we have to ignore the plus minus signs. So by taking the mod of D, then you just take the sum of those differences and you have to take the average, you have to take, and you will get the mean deviation. Okay. And the coefficient of the mean deviation is nothing but mean deviation with respect to median. We are calculating with respect to median. So this is the coefficient of the mean deviation. So here you are having one data is here given. So here you are having the one series 1 is there, another series 2 is there. You need to find the mean deviation of two different groups. Okay. So what you have to do? So you first calculate what is the median. So the first one, the median is going to be, what is that? So this is the how many elements for the first group? You are having the 5 elements. So this is going to be your median. Here you are having the 7 items you are having. So here this is going to be your median. Okay. And for the first group, you find the deviation from the median position. First one, 4000 minus 4400. So it is minus 400, but you have to take the, you have to ignore the sign. So you have to take the mod. So 400, next one 200. 0, then 200, 400. So these are the deviation. You take the average of that. Okay. Similarly, the second group also, you find the deviation, you have to take the average of that, and you will get the mean deviation. Okay. So for the first group, mean deviation is what is that? Mean deviation for the first group is 240, and second group the mean deviation is some 571.43. So that is the average deviation of the individual from the second group is 571.43. Then coefficient of mean deviation for first group is 0.55. Coefficient of mean deviation for the second group is 0.13. Okay, and if the frequency is there, then you just multiply with the frequency. That's it. Okay. If you are having the frequencies, then you have to multiply. Okay. So here you are having one example, the same problem, similar types of problem, and the frequency is there, and you just find the deviation, and after finding the deviation, you need to multiply the frequency, and you find and you average it, and you will get it the mean deviation. Okay. Similarly, for the continuous series also, you need to find it and you check whether you are getting the mean deviation. I will share these matters. And next class, we are going to discuss the standard deviation, coefficient variance. Those are the most important thing in